Good morning, everyone. As the aquifer in which water is stored, and thereby many peoples of the world, that is about 25%, they depend upon that water from which they can use or they can get the supply of water for their daily purpose. Now, the term karst is the German form of the Yugoslavian term krash, which means fast from investigating a narrow strip of limestone plateau in Yugoslavia and adjacent portions of Italy bordering the Adriatic Sea. In these regions, there exists a remarkable assembly of features which is mainly formed by subsurface solution of limestone rocks. So by studying or after studying the rocks of these areas near the Adriatic Sea of Yugoslavia and Italy, people give the landforms of these regions as karst, and from that, globally, whatever rock types or whatever landforms found formed due to dissolution of superficial as well as subsurfacial rocks, they are came to know as karst. So in modern geomorphology, the term refers to any typical rugged landscape formed by dissolution of the underlying bedrock. It is mainly formed or usually found in carbonate rocks such as limestone or dolomite. But apart from the carbonate, silicate rocks like quartzite or any other, there also karst landforms are found to occur. But in those cases, in case of silicate rocks, the formation of karst landscape requires a vast amount of time. That means millions or millions of years. And also, the landscape is not properly well developed. So thereby, karst landforms in silicate rocks is not so important to us. But as we know that the carbonate rocks, they are very much soluble to slightly acidic solutions. So in presence of acidic solutions, beautiful features or well developed landforms are formed in limestone or dolomitic rocks. So thereby the karst landforms for limestone and dolomitic rocks are very much important to us. Now, as we know that karst landforms are mainly solution features, that is, these rocks are involving into some kinds of chemical reaction with the slightly acidic superficial or subsurfacial water. So solubility of these rocks, these limestone and dolomites, may cause secondary porosity, because we know that limestones or dolomites are very fine grained, almost composed of uh, clay to silt size particles. So grain size is very fine, and permeability is also poor. So thereby, these kinds of solution features produce secondary porosity, which act as a passage for transformation for transportation of any fluid within the rocks, and also that secondary porosity acts as a good reservoir for any kinds of fluid. Not only that, this secondary porosity is sometimes cause subsidence also. So at times, now as I already told, the karst topography in silicate rocks, they are referred as silicate karst, and they can take many million years to develop. The term karstification is used to refer the process of karst landscape development. So all the processes by which the karst landscapes are formed, mainly by solution of carbonate rocks. The process is known as karstification. The world's largest limestone karst occurs in Australia's Nullarbor Plain, and Slovenia has the world's highest risk of sinkholes. Sinkholes is a subsidence feature. A depression occurs that we come into later slides and discuss about sinkholes. But for now, you just understand that sinkhole is a depressed feature formed in the subsurface, and it occurs due to solution of underground limestone. Now, from hydrological point of view, karst is divided into the surfacial forms that occurs in the surface or just in the soil zone, which is known as epicast, and the karst features also occurs in subsurface conditions, that is inside the earth surface, inside the soil zone, that is known as endocrust. So those occurs in surface or near surface zone are known as epicast, and those occurs in subsurface zones are known as endocrust. Now, formation of karst topography. As I already told you that in karst topography, the main factor by which these kinds of landforms are produced is the chemical weathering, particularly the chemical reaction or chemical solution of country rocks to some kinds of acidic solvent. So karst landscapes are generally the result of mildly acidic water acting on soluble bedrock such as limestone or dolostone in the following way. Now, the main solvent acts for the reaction is the carbonic acid. Now, carbonic acid forms when rainfall occurs, and we know that with increasing air pollution, the percentage of carbon dioxide is increasing in the atmosphere year after year. So thereby, when rainfall occurs, the raindrops reacts with the atmospheric carbon dioxide and they form the carbonic acid. Now, once these acidic raindrops, that is the carbonic acid mixed raindrops, they reach the ground surface, they will percolate through the porous superficial soil or rock, and within the soil zone they will further get more carbon dioxide and formed weak carbonic acid solution. So in two stages carbonic acid will form in a reaction with the atmospheric carbon dioxide as well as the carbon dioxide trapped within the soil zone. Now, apart from carbon, it was also seen that in these raindrops poured in the soil or poured in the exposed rocks of the earth's surface, some hydrosulfuric acid and even very dilute nitric acids are also formed, and these are formed due to reaction with some sulfates or nitrogen dioxide in the atmospheric gases. So although carbonic acid is the main acid formed due to reaction of water with carbon dioxide, but apart from carbonic acid, mild sulfuric acid, even hydrosulfuric acid, nitric acid can also form. And this acidic water, when they goes over the superficial exposed rocks and percolate along the fractures or bedding planes of the carbonate rocks, then all along the exposed rock surface, this acidic water starts react. And over time, these fractures, the minute fractures what the acidic solution gets, with increasing reaction, they enlarge the fractures, and ultimately after some time the rock is completely dislodged from its parent rock. Now one interesting thing is that whenever the reaction occurs and the fractures or joints are enlarged, then with increasing reaction the superficial area of the exposed rocks will increase time after time. So more and more reaction occur, more and more surface area is now exposed to new reactions. As you can see in this case, here it is a small fracture is there, and in this small fracture some kinds of acidic solvent is there which reacts with this exposed rock surface. So this acidic water reacts with the exposed rock surface, soluble them. Now more area is now exposed after the reaction. So this much area, this much superficial area of the rock is now available for reaction. So as more surface area is now available, so more reaction will occur. That is why more and more reaction will occur, more and more surface area of the rock is exposed for new reaction, and thereby allowing any kinds of fluids to pass through a basically um, less porous impermeable rock, and thereby they act as a good reservoir for underground fluids. Now what are the conditions essential for development of karst? The first and foremost condition for development of karst topography or development of karst landscapes is that at least the area suffers moderate rainfall. So there should be ample supply of rainwater. That means there should be ample supply of precipitation so that the atmospheric water vapor comes to the earth's surface, and during its journey path it already reacts with the atmospheric polluted gases and thereby form mild acids so that they can react with the exposed carbonate rocks of the earth's surface. So the area must be a humid climate where precipitation can occur in a sufficient amount. Secondly, there must be present at or near surface a soluble rock. So when the acidic water precipitates in form of rainwater, there should be some exposed rock so that the um, precipitated acidic rainwater can react directly. If there is no exposed rock surface, then this reaction will not occur. Thirdly, the soluble rock should be dense, highly jointed, and preferably thinly bedded. So there should be ample amount of pre-existing weak plains or weak areas through which the precipitated rainwater can percolate. The rock should be highly jointed, the rock should be highly fractured or thinly bedded. And these are used as the weak plains through which the um, acidic rainwater can percolate and react with the rock. At the same time, the rock should be dense. That means it should be strong enough to hold or to maintain its original structure. That is, it should not collapse when the reaction will occur, because after the reaction it should be uh, somewhat porous. It should be like this, it should be a little spongy, so there is ample chance to collapse the rock. So the rock should be dense, should be strong enough to hold its original structure. And lastly, the solubility of limestone is primarily governed by the groundwater flux. That means how much groundwater is supplied to that exposed rock surface, acidity of the water, and carbon dioxide concentration in the soil as well as in the atmosphere. So more and more carbon dioxide concentration or other pollutants like sulfates, nitrogen dioxides, they are in the atmosphere, more acidic solution will form during the rainfall. And that is why you may often heard that the Taj Mahal, the outer walls of Taj Mahal becomes yellowish day by day, and that is due a result of these kinds of chemical reaction, acidic reaction. Because if nowadays you visit Agra areas, there are lots of industries, and those industries uh, remove lots of pollutant gases like carbon dioxide, sulfur dioxide, nitrogen dioxide, carbon monoxide, lots of them into the atmosphere. So when precipitation occurs, that rainfalls reacts with those atmospheric gases and forms mild acidic acid. Mild carbonic acid. Now, this carbonic acid, that is H2CO3, when they react with the carbonate rocks, they produce the soluble bicarbonates, which is slightly yellowish in color. And that is why the walls of Taj Mahal or any carbonate rock, they are gradually chemically weathered. They are eroded. And as the soluble bicarbonates are slightly yellowish in color, so that is why limestone is gradually, or limestone looks patchy, uh, or limestone have patch of yellow colors in its wall. That is because it is a product of chemical weathering formed due to acidic rain. So these pollutant gases like carbon dioxide, their concentration in atmosphere or also in soil, they plays a vital role that how much reaction, how much acid solution will form. And for that, abundant vegetation cover and rainfall is very important. Now, if you look at the world major karst regions, you find that most of the karst regions are occurring in these uh, tropical to subtropical areas, and particularly among these tropical to subtropical areas, as we know that it is the uh, convergent zone between two global wind patterns. So here precipitation will occur sufficiently, and along these tropical to subtropical regions, particularly those regions are more susceptible to form karst landforms where there is ample amount of precipitation, that is where there is humid condition. So not only the equatorial to tropical subtropical regions are favorable, but among these conditions the humid condition, that means where there is ample amount of water vapor in the atmosphere, and from that precipitation in terms of rainfall will occur, those are the places where chance of formation of karst landscape by chemical solution or by chemical reaction of the exposed carbonate rocks is more prone. Now coming to the karst landforms or different kinds of landscapes produced by the uh, solution process or produced by the karstification way. The first produced by karstification is on the bare forms, that is those rocks which are exposed on the surface. Now in these exposed rocks or in these bared rocks, when they suffer a sufficient wetting, that is when the sufficient amount of acidic water pass over these exposed rocks, they forms pits, some ripples, flutes, bevels, and runnels. So all these are minute landforms. Like these, you can see these are very minute undulations found in the exposed rocks, found in the naked rocks. And particularly these kinds of landforms are formed when the exposed rocks is more or less horizontal or have a very gentle slope. These kinds of landforms are small in dimension, being at most at 1 centimeter wide and deep mostly. And in the case of largest form, like the solution flutes, it is about 1 to 2.5 meter wide and about 15 meter long. So mostly these are in centimeter range, but sometimes it will uh, go in meter scale also. Some large scale forms will also form. But the thing is, the rocks have exposed, the rocks have to expose in the surface, and the water, acidic water, mm, run through these exposed rocks and produce these kinds of minute undulations in the exposed rock surface. These are known as various terminologies according to their nature. Some are known as pits, ripples, also flutes, bevels, runnels, like this. Next is the when this exposed land surface, the chemical weathering or chemical solution is more intense, then the exposed rock surface becomes rugged in nature, and it is found that these limestone surfaces are pitted or grouped or fluted, and the overall exposed rock surface is known as lapis or limestone pavement. If you look closely, you find that this exposed rock surface has two distinct features. One is the square shaped or rectangle shaped some solid blocks of limestone or solid blocks of carbonates, and these solid blocks, these square shaped or rectangle shaped solid blocks, they are separated by some groove, by some linear fissures. As you can see also here, these are the linear fissures. These are the basically joints or fractures or bedding planes along which the acidic water runs through and enhances the solution process, enhances the chemical reaction time after time. So ultimately, the exposed rock is divided into some kinds of blocks which are separated by some kinds of fissures or some kinds of deep fractures. These fractures or fissures are known as Greek, and the blocks, the individual blocks, are known as cleans. So basically, the lapis or limestone pavements is a resultant structure of the combination of some Greeks and cleans. Greeks are the fissures or fractures, and cleans are the blocks of the limestone. Now, it is sometimes found that the solution process is not so intense, and on these cleans, on these blocks of limestone, some very small depressions which is resultant uh, of a solution reaction is found. These kinds of small depression within the cleans is known as carene. Next is the pinnacle cast. Now, when the exposed rock surface, as you can see in the previous case, that uh, the in the exposed rock surface, chemical reaction will occur in the joint planes or fracture planes. Now, when this process becomes more intense, the creeks, they becomes very large and deep. So often it is found that instead of those creeks and plains, there we found some limestone pillars when the chemical weathering is more intense. And it is particularly found in China, where these kinds of pillar-like structure, often height of about 1 to 35 meter and the diameter of about 1 to 20 meter, are found. In China, particularly in uh, Yunnan areas, these kinds of pillar-like structure resulting from the chemical solution of carbonate rocks are found covering about a 350 square kilometer area. So from those areas, it is known as pinnacle karst. So it's basically an enhanced, more intense uh, process of chemical solution through the fissures, through the creeks, by which these kinds of towers are produced. Now, apart from pinnacle karst, it is often found that there is an assemblage of exceptionally wide creeks, and due to this wideness of creeks, that means wideness of fissures, the exposed rock is now remained as some ruined and some relics of ancient village or ancient town. As you can see often in some ancient village like the Harappan civilization, the Mohenjo-daro civilization, when people dug those ancient remnants, you may found these kinds of ancient time pillars or remnants of houses or any kinds of construction. So here this is formed, or this looks like those ruined villages or ruined towns, and it occurs due to the uh, intense weathering along the Greeks, and due to that the Greeks becomes very wide, and for that there exist some miniature blocks or city blocks like a ruined town. So these kinds of structures is known as ruiniform karst. Next is the cone karst. Here in the uh, cone shaped exposed land surface is formed, and this cone karst is divided into two types. The first one is the cockpit karst, where water dissects the limestone layer with numerous trenches, numerous wide trenches, and as a result, a network of deep valleys are produced, which is surrounded by these kinds of limestone mounds or limestone ridges in between. So this type of mounds, limestone mounds separated by wide um, fissures, wide valleys formed due to weathering of carbonate rocks, is known as, this landform is known as cockpit karst. Now, when the cockpit karst formation is over, now if there is more chemical weathering occurs, so at this time when the water passes through these valleys, only the lower portion of these mounds is now exposed or is now available for chemical weathering. So now chemical weathering will occur only in these lower portions, and with time these lower portions are eroded, and it becomes, these mounds or these hills becomes more steeper and steeper, and ultimately they form these kinds of more or less vertical towers, straight towers. These kinds of landscape are known as tower karst, as they looks like a tower. Next type of landforms, or rather you may call it's a relict soil formed due to karstification, which is known as terra rossa. The material of terra rossa may be lacking on steep slopes, particularly these kinds of relict soils are found in gentle slope rocks. The these kinds of red clay soil are found particularly rich in some iron oxide minerals. The chemicals are rich mainly in aluminium, iron, silicon, and they particularly look similar in appearance like a lateritic soil. But the process of formation of lateritic soil and these kinds of soil in the karst dominated areas is completely different. So although it appears like a laterite, but it is not lateritic soil. The process is extremely entirely different. So these are mainly surface and near surface solution results producing by descending groundwater, which leaves a residue of red clay soil and maintaining the surface and extending down into open joints. So these kinds of exposed clay soil structure which looks like laterite are known as terra rossa. Next is the sinkhole. So this is a very important structure or landform formed in the carbonate terrain, and by far the mostly found structure or mostly found landform in the karst region. Now these are basically bowel shaped or funnel shaped or cylinder shaped depressions formed in the surface or in the subsurface conditions. It may be several meters in diameter, and in areas they may range from few uh, feet to thousands of feet, and even um, several kilometers also. So their size may be small as well as very large also. The most common form is obviously the funnel shape, as you can see in this picture. The upper exposed area near the surface is much wider, and as we go inside, the area becomes narrow, the diameter becomes narrow, but the shape may vary from place to place. Now this type of solution depressions are known as sinkholes, or sometimes they are also known as swallow holes. These type of sinkholes are mainly divided into two groups or two classes. First, those which are developed slowly by downward protrusion of acidic solution beneath a soil mantle without more or less any physical disturbance of the exposed rocks, and produce these kinds of depressions in the surface of or subsurface rocks. These are known as solution sinks. So a acidic water percolates through the exposed rocks or soils and reacts with this rock and thereby produce solute this material, and thereby producing these kinds of depressions in the surface. So these are simply formed due to solution. These are known as solution sinks. At the same time, there is another type which is developed by collapse of the rock above an underground void. So in this case, a void produced in the subsurface condition, and after some time the rock over that void, they are collapsed. So due to this collapse, these kinds of depressions is observed from the surface. So these are known as collapsings. Now the karst region, particularly in Yugoslavia, in these areas the solution sinks are also known as doline. Steep-sided, rocky and abruptly descending forms resulted from the collapse of the country rock. Those are known as simply collapsings. So the term doline is similar in meaning with solution sinks, whereas collapsings are known by its own name. A variant of the doline is also known as solution pan, where the depression is much shallower but may be covering a larger area than the solution sinks. So instead of solution sinks, you can see the depression is local, but it is more deep. In case of solution pan, the depression is shallow but covers a larger area, like a pan, what we see in our kitchens. So from that, it is known as solution pan. Now at times, it is found that these kinds of sinkholes that may be produced by solution or that may be produced by collapse, they intersect the local water table. So it is found that the sinkholes, they are filled with water. So at that case, the sinkholes are known as sinkhole ponds or karst lakes. So when these holes intersect with the local water table, suppose this is the local water table, so the sinkholes are also filled up with the water here also. So at that time, when the sinkholes are filled up with water, it is known as sinkhole pond or karst lake. Next karst feature is known as karst window or karst fenster. This term has been applied first by Mallotin in the 1932 to indicate an unroofed portion of an underground stream course. Now, these kinds of features formed when there is a passage in the subsurface condition, in the underground condition, through which a stream or flowing water pass. But with time, the surfacial rocks, that is the roof rocks over this passage, they are collapsed, and due to that, there makes a hollow, there makes a window by which peoples are able to see the subsurface fluid of water. So it makes a narrow passage by which we can observe these kinds of subsurface streams. And you can see that in subsurface conditions, these kinds of streams emerge from one side of the carbonate rocks and disappears in the other side. So only a very narrow portion within this subsurfacial uh, passage is observed due to the collapse of these roof rocks. So now this roof collapsing portion is act as a window through which we can see the subsurface conditions, particularly the subsurface flowing stream. So these kinds of structure is known as Karst Fenster or Karst window. A Karst Fenster is caused by caving in some portions of the roof of a subterranean stream, thus making some of the underground stream visible from the surface. Next is the landform known as UVALA, which is a Bosnian term, that is particularly this terminology is used in Bosnia, and it is most commonly applied to some large depressions resulting from the collapse of extensive roof sections over the underground courses. So basically it's a extended extended version of the collapse sinks, a larger version of collapse sinks. And it is thought that these uvalas are formed due to compound sinkholes, which formed by convergence of two or more sinkholes. So due to the combination of two or more sinkholes, a larger area is found to be affected by these kinds of collapsed depressions. At that time, it is known as uvala. The next type, which is far larger in dimension, it is known as polje. It is also a typical Bosnian term, that is in Bosnia it is used, but here the shape of the depression is somehow elongated, and the floor is more or less flat. As you can see in this picture, floor is more or less flat, and it is surrounded by some steeply enclosing carbonate rocks. As you can see in this flatly depressed portion, it is surrounded in its two sides and in almost in all sides by these kinds of steeply inclined carbonate blocks. So it's more or less like an uvala in larger dimension, with somewhat elongated in shape. If you compare the aerial span of uvala and polje, uvala is uh, only covering few acres, whereas a polje covering many square miles. So polje is much larger in dimension and as well as elongated in shape, and also these are flat um, bottom and surrounded by steeply inclined carbonate rocks. Now often it is found due to the local water table condition, the polje contains some amount of water and forms some local ponds or local lakes. So at that time those lakes are known as polje lakes. Now it is also found particularly in the Mediterranean region that some kinds of exposed uh, isolated uh, hills like structure within the polje areas, within the polje floors. These kinds of exposed hills, isolated hills, are known as humes or Papino hills. The sinkholes, all different kinds, it may be the solution type or it may be the collapse type, are sometimes so effective that it can accommodate or it collect all the superficial runoff, that is the water of the superficial streams, such that here you can see that when a stream is passing over these sinkholes, all the water goes into the sinkholes. So only those larger streams which have much more supply of water, they can pass this sinkhole area. without completely disappearing in the sinkhole. But in most cases, the smaller streams, the smaller rivers, they all when they all face during their path in their valley, these kinds of sinkholes. So all the flowing water goes in the sinkholes, and thereby it appears that the stream disappears suddenly within this sinkhole. So these streams are known as disappearing streams. Now, if there is a mountain, as you can see in this picture, there is a mountain, and that mountain is affected by the karst topography, karst landscapes, and have a sinkhole, and a river is flowing in these areas and disappearing in these sinkholes, then often it is found that in the opposite side of the mountain, again the stream reappears, so thereby formed some kinds of spring, which is known as karst spring. So in this mountain area, in the one side of the sinkhole, the stream disappears, and in the other side, through some fissures, again the stream came out into the superficial conditions. So reappearance of stream in the other side may occur, and this reoccurrence, um, from the distance of disappearing and reappearance of stream may be several miles or several kilometers distant also. So from the side of a hilly terrain, when a subsurficial water flow is again coming to the surface and forms some kinds of springs, this is known as karst springs. Now, a valley that ends suddenly at the point where its stream disappears, that is in these sinkholes, and all the stream water goes underground, these kinds of valleys are known as blind valley. At the same time, if there is a large stream which is previously flowing through a channel, flowing through a valley, and uh, during some course of time, if suppose within this valley some kinds of sinkhole occurs, then all the stream water is now flowing within this sinkhole. That means this sinkhole capturing all the flowing water. So the remaining portion of the stream valley, that is the downstream portion of the valley, now becomes dry. That means that portion of the valley did not face any kind of flowage of water within that particular channel. Only in the exceptional condition, that is particularly during the flood condition, when the sinkhole does not able to accommodate all the stream water, then only the downstream portion of the valley receives some amount of flowage. These kinds of valley is known as dry valley, because in most of the time of the river, the stream disappears within the sinkholes, so the downstream portion becomes dry. That downstream portion of the valley did not suffer any kind of flowage of water. So that is why these valleys are known as dry valley. Another feature which is known as natural tunnel or bridge. This is basically an underground route through which the water runs. It is called natural tunnel, and this natural tunnel have a overhead roof. It may be long, but with time, the roof gradually collapses, and ultimately it forms a very narrow passage like a bridge. So that bridge is known as natural bridge. It's basically the overhead roof or overhead passage over a natural tunnel. Now, natural tunnel or bridge can be formed in various processes. In coastal landscape, these kinds of roof, that means underground passage or and overhanging bridge is also formed. But in coastal process, these are formed due to mechanical weathering and mechanical erosion. So as these kinds of features or these kinds of landscapes are formed due to various reasons, so often the tunnels or bridge which formed due to karstification, they are known as karst tunnel or karst bridges. The next, and again a very important feature found in nature due to the karst processes, is known as cavern or cave. A cave is defined as a natural subterranean uh, or subsurface passage or void space. The cave may be, or the subsurface passage may be simple or it may be complex. The passage may extend horizontally as well, it may extend vertically, and it may occupy more than one levels also, and that variation in level is basically depending on the supply of surface water as well as the local water table condition. Now, dry caves, sometimes we found caves which are particularly dry, because we know that these kinds of caves are resultant of a solution feature, so there must be some kinds of water. But often we found dry caves which is basically resultant of the karst cycle, later stage of karst cycle, that the karst cycle will come later. Now often we found these kinds of karst cave landform which is more or less dry, that is there is no supply of that much of water, subsurface water, and it is often found that it has two or more levels. So at that time, these kinds of caves are known as galleried caverns or galleried caves. It looks like a gallery, different stages, different levels of gallery. So from that, it is known as galleried cage or galleried caverns. Now, smaller caverns usually show a rather clearly that development took place along some linear direction, and it is largely controlled by joints and bedding planes. But when there is ample amount of or sufficient supply of acidic water, and when the chemical weathering is more prone, then the linear direction may be diverged, may not be followed. So in every possible direction, chemical weathering may happen. Now, caverns exhibit a variety of depositional features. The most striking features are usually the accumulation of calcium carbonate on the ceilings or on the walls as well as on the floors. The term cave travertine is particularly used to the any kind of cave depositional forms or cave depositional structures. So cave travertine, it's basically a umbrella term which covers many kinds of depositional structures found within the caves. One famous structures formed due to cave deposition of carbonates is known as dripstone. The name dripstone was given because these kinds of structures are developed or these kinds of structures are formed by water dripping from the cave ceiling. The first type of dripstone is known as stalactite, which includes the downward extending carbonate deposition, that is when the uh, water dripping from the ceiling of the roof or from the ceiling of the cave and produce these kinds of vertical linear structure hanging from the cave ceiling or cave roof. These are known as stalactites. Sometimes these droplets of calcium carbonate rich water is fallen in the uh, floor of the roof, floor of the cave, and from that some kinds of depositional carbonate structure arise or starts to form from the floors, and they will grow upward in the vertical direction. These kinds of structures are known as stalagmites. And when the stalactites, sorry, this should be stalagmite, it's a mistake from my side. This one is stalactite and this one is stalagmite. And when this stalactite and stalagmites merge with each other, they touch each other, they will form these kinds of column or pillar like structures which is continuous from its roof to its floor. These are known as columns or pillars. But in all these three cases, if you look at the growing direction of the carbonate depositional landforms, that is whether it is stalactite or stalagmite or columns and pillars, they all grow in the vertical direction, that is more precisely in the perpendicular direction from the cave roof or uh, cave floor. But apart from this, in the cave rocks we found often some uh, varieties of these kinds of depositional structures. As you can see in these pictures, that here not only the depositional forms are producing or occurring vertically, but the deposition or the structures also form in horizontal direction or any other possible directions. So the individual parts of this uh, carbonate deposition may grow upward, as you can see here. It may go horizontally, it may grow obliquely, and it may go uh, downwards side. So in every possible direction, these kinds of growth can happen, and this is a special form which is known as helictite. And these kinds of helictite forms occur when there is less amount of water supply. So just the depositional landforms or depositional structure is wet. There is not so much water that it uh, comes exactly at the bottom portion of the structure. Instead, during its journey, it just wet the one side of the structure, one side of the um, hanging carbonate structure. So thereby, it will grow in different directions. Now, apart from dripstones, there are some other kinds of structures are also found in the caves or in the caverns, which may be formed in a due to continuous flow of water, that is continuous running water, and those are known as flow stones. And we also found rimstone, which are found where waters overflow from the shape and size, and it is particularly found in some portions of the cave. But the most famous of cave structures is these kinds of dripstones, the stalactites, stalagmites, and column and pillar structures. Now, coming to the karst cycle, all these karst landforms so far we studied, they are forming in different stages of a karst cycle. And this cycle was first proposed by Physics. Physics recognized four stages of karst landform formation. In the first stage, that is in the youth stage, it begins with some superficial drainage over an limestone, exposed limestone rock, and which suffers some chemical weathering. Mainly in this stage, the lapis or lime cast pavements are formed. No such cave system or cavern system is produced in this young stage. So it is the superficial condition. Superficial chemical weathering happened in the limestone rocks. In the second stage, that is in the maturity stage, in this stage, the superficial streams goes underground. So maximum underground drainage found in this stage. The surface drainage is very limited and often they are found to end or disappear in the sinkholes or sinking creeks and producing some blind valleys or dry valleys. Cavern networks are characteristics of this stage, that is cave system produced, and this is the stage or this is the time when maximum karst features are formed, maximum karst features are developed. So this stage is very important for formation of karst landforms. The third stage is known as the late maturity stage, which marks the uh, beginning of the declining of karst features. That means karst cycle is gradually or karst process is gradually diminishing. Karst windows are formed, that is a collapsing of the roof formed, and this expand to large uvalas or sudden polges are formed in these, and sometimes humes or papino hills are also found. So this is the late maturity stage when mainly collapsing of the roof occur. And the last stage, that is the old stage. In this stage, it is marked by return of surface drainage. So as we know that in the U stage, the superficial streams goes underground. So again, and this fourth stage, the subsurface stream again come back to superficial condition, and it we found some isolated structures like humes or papino hills. They remain as some remnants of the original limestone terrain. So gradually, um, from youth stage, the castification process started. It becomes maximum in the maturity stage, and after maturity stage, the castification process is gradually declining, and in the old stage, the subsurficial drainage again comes back to the superficial conditions. So that's all. That's a brief uh, idea about the karst processes and the different types of karst landscapes formed. Thank you.